Hello students, I am sure the length and title of this video is very encouraging to you. Maybe you have a test tomorrow morning. Maybe you have a test this morning. Maybe I am right in front of you about to start the test and you are now looking at this video for the first time. Regardless of what it is, you'll learn this very quickly. Alright, now we do log differentiation to make any question simpler if it involves quotient, having to use a quotient rule or a product rule, because as you know, quotient rules and product rules are multi-step rules. Alright, so we use logs, the properties of logs, to split a product or a quotient into individual terms, where at that point we just do simple differentiation. Alright, so let's say this is the question. Find dy dx of this. First step, log both sides. We'll be using ln, since we know the rule very, very well. And then both sides of the equation. Then we use the log rule that says log of a divided by b is equal to log a minus log b. That's what we did here. From this step to that step, we still didn't differentiate, not because the 4 went down there, we didn't differentiate, we just used the rule log of x to the n power is the same as n log x. We did the same thing with this power, and that's why we have this here. Now we differentiate finally both sides of the equation. So differentiate this with respect to x and this with respect to x. Now we could differentiate y with respect to x only because we defined y as being a function of x. So as we discussed, if we differentiate ln of a function of x, the answer is 1 over that function of x multiplied by the differential of what that function was. Remember that? One step at a time. Good. Now, what's the differential of 4 ln x? It is 4 multiplied by ln x, 1 over x. Minus 2, differential of ln x plus 1 is 1 over x plus 1. If you differentiate x plus 1, of course, that is just 1. Now, what's the problem? What do we have over here? 1 over y times dy dx. But that's not what the question asks you to find. The question asks you to find dy dx. So, what we do, this y, we multiply both sides by y, or as we learned in secondary school, we throw over the y, right? So we throw over the y, multiply over here. But what was y? Y was x to the 4th divided by x plus 1 to the 2nd power. This was y originally. Right? So we just neaten this up a little bit, put the original definition for a y, and that is it. As simple as that. Alright? A second example is here. Again, we have kind of a to be involved to do this the regular way, because we have a product rule at the top with a quotient rule overall. So again, we want to find dy dx of this. To make it simpler, ln both sides of the equation, which we did in step 2 here, and ln of all this a divided by b is equal to ln a minus ln b, and then I further split this, which is a product, into ln this plus ln that. Oh, I didn't say this times this plus this times this, you know. This is ln of a. B is equal to ln a plus ln b. Get it straight. Get it straight. Alright. Next, ln y. No, sorry. Next, after you make it as simple as possible, you could make this simpler, but I'm not going to do that now. After making this as simple as possible, we now apply differentiation. So we find a differential of both sides of the equation and just put d dx. And for the differential of ln y is 1 over y multiplied by the differential of y. Right? Here we have 1 over x plus 3 times, when differentiate, sorry, 3x plus 1. It's 1 over 3x plus 1 multiplied by the differential of 3x plus 1, which is just 3. differentiating this, remember we spoke about in shows. Just if you see more than one rule, function will function, just take your time. Don't rush the brush, right? To differentiate ln of a function of x is 1 over the entire function of x. You see we didn't put sine 2x here, we didn't change anything. 1 over the entire function of x multiplied by the differential of what a function of x was. If you differentiate sine 2x, you get, sorry, cos 2x, you get minus sine 2x, but wait, this was also a function of x and not just an x. So then you have to multiply by the differential of what this is. Now this is 2x, so you multiply by the differential of 2x, which is just 2, and now you're finished differentiating this term. You apply the outermost rule first, then you apply the cos rule, then you apply, well, the basic 2x or integer rule. Now here, if we differentiate, ln of 2x is 1 over e to the 2x, multiplied by the differential of this. Differentiate e to the x is just e to the x, but then this wasn't just x, this was a function of x, and then you multiply by the differential of this function of x too. You know, if you really focus with this, and this thing is very, very, very simple. Alright, now here I just did some neatening up, put everything neat. Sine 2 minus sine 2x over cos 2x is equal to tan 2x, well, negative tan 2x. This 2 I just brought that in front there. This and this cancels out and is left with 2. And like once again, they ask for dy dx and not 1 over y times dy dx. So I just make dy dx the subject of the formula, and I redefine y as what it originally was, and that is it. Final example. Look at this. Even though this has an ln inside, we will still do log differentiation, because you can do it anytime. You have to be comfortable to do anything at any time, right? So we have this, and we ln both sides for the sake of splitting everything into individual terms. So of course, ln of a divided by b is ln a minus ln b, and then I further split this. This is something to a power, so with log rules, log of x to the n is equal to n log x. I know I could do the same thing with this and just call this 2x times ln e, which is 1, but I'm not going to do this because I just want some, you to have some functional function practice. Alright, so I wouldn't break this down further than this. Next step, differentiate both sides of the equation. So we just apply the differential, the sign or notation, sorry, and then we differentiate. If we differentiate, well, we did that already. ln of ln x. ln x here is the function of x that is within this bigger ln x. So if we differentiate this, it's 1 over ln x, which is the function of x, multiplied by the differential of ln x, which is just 1 over x, and that's it. Well, this one is simple, and we do some neatening up, and we're done. You can look at that there. I owed you some notes. I had made a promise to you, which I never fulfilled, which is making I said I would have given you how a book is supposed to look like for one of the problems that got messy on the board because it was long before we introduced log differentiation. I didn't keep the promise, but here you can use this. This is the same thing. I'm just a messy question before we use log differentiation. This is the same question here. We don't use log differentiation. You can peruse this later. You see we end up with the same answer as we did using log differentiation, but this one was much more involved. Right? Again, if you want to do this on your own and get the same answer, that's okay. If you have problems, you can still visit me in the office or call me. And that's it. Log differentiation in 10 minutes. All the best.